Hello everyone. So welcome back to our channel, that is AI Next Generation. So in the previous two video of the CNN, I hope so you have gone through the video where I have explained you about the introduction part of the CNN, that is a convolution neural network, what the CNN make difference for the ANN, why we are using image data for the CNN, and why CNN is giving us more accuracy as term of the ANN. So I hope so these things are clear to you. So this particular video belongs to the first operation we are just performing in the convolution neural network, that is a convolution operation. So this is the first step we are just going to take whenever you are just using the CNN models, and this is the most important step in the CNN network. Whenever you are just building the CNN network, you are just defining the convolution operation for that. So how the you are just providing the images and how the dimension of image is reduced, you can just see with the help of convolution operation we are going to see. Okay, so first of all, here I will make you clear. So whenever if you are just if you know about the filter or kernel or the feature detector, so just keep in mind that the filter, the kernel and the feature detector, they three all are the same. Don't be confused, some they are using as a filter, some they are using as a feature detector, and someone they are using as a kernel. Okay, so basically means that how many filter you are going to use for that particular image, because every feature detector will have different operation. Some filter will be related to the edge detection filter, some filter will be related to the shape detection filter, some filter will be related to the size detection filter. So this is the in the CNN you are just performing, you are using n number of filter, so that you can apply on that particular image and you can just get that particular output. And from that particular output means from that particular image, that particular filter will just extract on the basic of what you are just providing, which filter you are just providing. Okay, but even also you don't have to bother how which filter you have to give during the CNN time, training time, because during the training time you have to just only define how many filter you are going to use for this particular CNN or this particular model. You are just building the CNN model, you don't have to bother about how many that is a which type of that is a filter we are going to use, or kernel we are going to use, or feature detector we are going to use, what type of we have to provide, that is automatic done by the CNN during the training time. So they during the back propagation they are just updating the filter of the different what kind of image you have just provided. On the basic of that, the filter will able to capture what is there in the image. Okay, so now the basic thing is clear to you. Suppose I will just give you with the basic example, with this particular basic example, I hope so you will be clear. So suppose you have the image, the image size is 7 cross 7, you can just cite because 7 rows you have and 7 column you have, clear. And in this particular you don't have any colorful image, leave it about the colorful image, you are just dealing with the grayscale image that has only one channel, that's a representation of this particular dimension of this particular image is 7 cross 7. And then after what you are just using, you are using a feature detector, let's suppose it is a detection filter, let's suppose. Okay, so what they are also called as a feature detector or kernel or filter. Don't be confused, among three you can use any word, it's up to you. Okay, so whenever you are just using feature detector of 3 cross 3 size, okay, and this is the 7 cross 7 image size, so you will use this particular feature detector on top of this particular image, so that you will get some output on the basic of multiplication of these. So how we are getting, or how we are just doing the multiplication of this is the really important things you are just performing in the convolution layer, that is a convolution operation. So here you have the 7 cross 7 image, now this 3 cross 3 will go to that top of this particular image. Okay, that is a 3 cross 3, this is a feature detector you have just defined, that's dimension of this particular feature detector is 3 cross 3. We can use 5 cross 5, we can use 7 cross 7, we are just taking for an example, if you are just understanding with the particular example. So whenever we are just building the model, so at that time we can just see whenever you are using a huge amount of data set, at that time you're just defining feature detector as 5 cross 5 or even the 7 cross 7. But whenever you're just dealing with a small amount of data set, you are using only 3 cross 3 number of size of that particular filter, clear. So you are just placing this one in top of this particular image, that is a this is the 7 cross 7 image, and this is a 3 cross 3 filter. And then after there you are just doing the multiplication of this particular matrix. And how we are just doing the cross multiplication of this particular matrix, I hope so you have just gone through the matrix in the class 11 or class 12, the matrix multiplication, even in the graduation, if you are just coming from the background of this particular engineering background, so you already have just one chapter in the particular first year or second year of the BTech. That is basically matrix multiplication or something. So I hope so you I don't have to say how the matrix multiplication is going on, but here I will explain you how it is performing in this particular image. So this particular 3 cross 3, you are just keeping on top of this particular image, that is a 7 cross 7. So this particular 3, now you are just extracting this 3 cross 3, that is 0 0 0. You are able to see 0 1 0 and 0 0 0. Clear? And now this particular what's there in this particular filter, the filter is a 0 0 1 1 0 0, and there is a 0 1 1. Okay, so this is the filter. The pixel represent inside this particular filter is 0 0 1 1 0 0 and 0 0 1. Okay, 0 1 1. And this particular image you are just cropping up. You can just take, you are just cropping up 3 cross 3 so that you can just perform the matrix multiplication. Now you are just multiplying this one is the first row and first column of this one image, and with the first row and first particular column with this particular filter. So 0 into 0 plus, then after then you are just again multiplying second column first row, and then after similar you're just multiplying second column first row, and similar third column first row and third column first row. Means 0 into 0 plus 0 into 0 plus 0 into 1 will be 0 plus 0, and then again with the second row first column, second row second column, second row third column, similar third row, that is the third row first column, third row first column with this third row second column, and similar you are just multiplying with third row second column for the feature detector, and third row third column for this particular image, and you are just multiplying third row third column with this particular feature detector. So after multiplication you are just summing off 0 into 0 plus 0 into 0 plus 0 into 1 plus, so you are just summing off, and what you are just getting the output after multiplication of this particular 3 cross 3, you will get somewhat output as 0. So you will now put as, you will just put as a 0. Now again it will just slide at one time. So now why it has been slide, or you can just say window size you have just taken as a 1, they are called in stride. So stride, you can just take an example. So you, whenever you are just taking a step in the stair, so how many stair you are just skipping? Whenever you are just, you are not skipping any stair, you are just going one stair at a time, then at that time you are just saying that stride equal to 1. But whenever you are just skipping two stair at a time, means you are just skipping one stair and then jumping on the second stair. Okay, so at that time you can say that your stride will be basically your 2, means you are just taking, you are just moving two stair at a time. Whenever you there is a stride 1, means you are just jumping one stair at a time. Okay, so one after then another after another, that is whenever you are just jumping one at a time. But whenever you are just jumping two at a time, means you are just skipping the two stair at a time, that we can call as a stride equal to 2, means you can take a sliding window of 2. But by default the stride will be always 1 whenever you will do the coding part, and even whenever I will just perform the CNN network model, whenever I will just build, so at the time you will see we are going to use the stride, and stride by default we are just going to use as a stride equal to 1. If you are to change stride equal to 2 or stride equal to 3, so it's up to you. After that you can just change or modify that particular default value of that is a 1. So whenever you have just taken stride equal to 2, after multiplication of this, now it will jump to this particular matrix, that is a 0 0 1 1 0 0 0 0 1, and similar it will multiply with the same as it is, and how it is going to multiply, and you will get some result. Here you are just getting 1 into 1, rest it will be 0 into 1 something 0. So after summing of all the number matrix multiplication, you will get 1. Okay, so again you will just take a stride equal to 1. You have taken stride equal to 1, means again it will skip, it will jump one column at a time. Now you can just see it will be like this one. So now and it will just goes on, and you will have some matrix multiplication on that. Okay, so and again it will goes on like this. Clear? So you are just doing the matrix multiplication of this by using the stride. It means you are just using stride equal to 1, you are just keeping one column at a time. But whenever you are just done with this particular stride, okay, whenever you are done with this, then again it is going to the first particular row. Okay, and it will only jump first row. Now it will go for the second row. Okay, so already the first row it has been completed. Now it will jump for the this particular second row. Clear? So now this particular second row it will just execute, that is a 0 1 0 0 0 0 0 0 0. Okay, so this particular row it will just take, and it will just do multiplication of this. Again you will get some output here. Again it will skip one column, again one column, again one column, and then after, whenever you are just going to this particular place, then after that there is no matrix multiplication means there is nothing. So at that time again it will just stop, and again it will just jump to the third row. Again it will skip first column, second column, third column, one after another, and then again after completion of this, again it will jump to the fourth row. Okay, so it is going to use like same as it is. And here you are just getting the more number of plus, means 1 into 1 you are getting as 1, and here also 1, here also matrix multiplication it comes 1, and here also 1. By summing of all the matrix multiplication of this particular area of this particular image and this particular filter, you are getting as a 4. Means more number you will get, the most important feature you are getting in that particular area of the image. Because this particular filter, let's suppose, is related to the shape detection filter. So shape detection filter means this particular area, that is the most crucial shape for this particular image. Okay, so that's why you are getting more number of you can just take after matrix multiplication you are getting more number of value there. So more number of value means most important feature there is existing. Okay, whenever there is a 0 means there is no any such important place, or there is no such important value there. Okay, so you can already you can just see this thing after matrix multiplication you are just getting this one as a output. This is your final dimension of this after performing the first convolution operation. But this particular 7 cross 7 image, now you have just reduced this one into 1 2 3 4 5 cross 5 images. Okay, so you are able to reduce 7 cross 7 image to a 5 cross 5 image. Why? So you are able to see, because you are by 7 cross 7 there was 49 total number of parameter, but whenever you have just applying the convolution operation, you are using the some filter and you have just reduced the dimension of image, that is a 5 cross 5, that is a 25 parameter learnable, you can just say, parameter. So you are able to see there is a huge difference between this particular after performing the convolution operation. So this is you are able to reduce the dimension of this particular image. You are just dealing with that particular area of the image which has the most important feature. You are not dealing with the edge detection. So in the edges part you are not getting that much information as we are getting in the middle portion of this particular image. Okay, so this is the first you are just performing the convolution operation. Again, in this particular slide I have just mentioned that even after reducing the image size, so you are able to, you are just losing some information, because whenever your image size is 7 cross 7, and that definitely you are just reducing the size of that particular 7 cross 7 as 5 cross 5, means you are just reducing the dimension of image, but also you are just losing some information. But that particular information is not very crucial to classify any particular object. If you are just going for the cat and dog, so if you from this particular image you are just extracting the cat, where the particular cat it is located, you are not dealing with the edges of this particular image, because at the edges you will, that is a useless pixel. At the edges there is no such important features, there is no such important feature. So you are just looking at that particular middle portion of this particular every image. So at that middle portion you are getting more important features, or more important features on as compared to the edges, you can just compare. Okay, so this why you are also losing the information, but side by side you are just reducing the dimension of image, and from that particular dimension you are just extracting the most important feature from that particular image, so that whenever you will fit to the ANN model, so the two plus point you are just doing, you are just reducing the size of your image, and also what you are just doing, the learnable parameter is reducing, and you are just decreasing the training time also, so it will able to learn, and you are not keeping too much burden to particular ANN model. Okay, so this is the plus point what you are just performing in the convolution operation. And this way we have just created the first one. I will say you the feature detector or kernel, or the filter. Here we have used one, but real time you will just define 32 filter I want, or 16 filter I want, or 64 filter I want, or 128 filter I want. That will depends upon your data set, how huge data set you are just going for, or how huge you are just building your model. If you are just going for the small data set, so at that time you will provide 12 number of kernel size, or you can just say feature detector, or number of kernel, or number of filter. If you are dealing with 10 millions or 1 millions of data set, at that time you will say we are just starting with the 64 and we are ending with the 512 total number of filter. So this is how we are just defining. Here we have just created as total number of 10. Okay, 10 feature maps. Okay, so what will the dimension of new image will be? Basically your new image will be 5 cross 5 into 10. Okay, so because 5 cross 5 is your image, that after first convolution operation you are getting 5 cross 5. This is only for the one particular filter, and then again you are taking the second filter where suppose this particular filter is related to the shape detection, another filter will be related to the size detection, that the pixel representation of the size detection will be different for this particular shape detection. Now size detection will also perform the same convolution operation how it is performing, and you will get an output as 5 cross 5. Okay, so this particular 5 cross 5 you are getting for the feature that is related to the shape detection, let's suppose, and then again 5 cross 5 you will get for the size detection, means 5 cross 5 into 2 you will get. But if you are going to use 10 number of filter, then what the output dimension will be 5 cross 5 into 10. Okay, so this is how you are just going to represent this thing in the CNN model. Even whenever you will just build the CNN model, you will be more clear at that, because we are going to build with the scratch with the help of PyTorch. So in the PyTorch you are just defining, and you will go step by step how after one convolution operation what is the dimension of the image. Even I have just uploaded in the PyTorch series how to build the CNN model, if you can just go and watch that particular video. But still I will also go in this particular series, I will just create a model that's related to the CNN for real world data set, how we are just creating, and how you are after every convolution what's the dimension of your image. Okay, and how many filter you are going to use. This all thing we are going to cover in this particular coming soon video. Okay, so this is the one example I can just sorry, this is the one example I can just give you. This is the 7 cross 7 image size. Okay, so 1 2 3 4 5 6 7 total you have 7 rows and 7 column. Okay, and now you are using the 3 cross 3 filter size. Already we have just seen this thing same as it is, and then after here we have just used the stride equal to 2, then you are getting your output dimension of image is 3 cross 3. But whenever you are just using stride equal to 1, you are able to get the output dimension is basically your 5 cross 5. So stride is basically how many step you are just taking. So, and there is also one formula, because this is the type of question is generally asked in the interview. So the one question will be that if I am just using a image size as 7 cross 7, and my stride I am for that you are using, I am using as a 2, and padding we are using as a 0. The padding purpose is basically I will just describe this thing in more detail. What do you mean by padding? For just now, just let me it be the concept of the padding. So there are two type of padding we are going to see, that is a valid padding and there is a same padding. Okay, means that particular padding you are using whenever you don't want to reduce the dimension of image. Okay, so at that time you are going to use the padding. Means if you have the 7 cross 7 image size, you want after convolution operation also you want the same dimension image, that is a 7 cross 7. Here you are just reducing the 3 cross 3. At the time of using the whenever you will use the padding, you will not reduce the dimension of image. Okay, so you will get same as it is. What the input you are just providing, dimension of input same as it, what after convolution operation you will get the same dimension of the image. Okay, so this thing we will see in the again in the coding part also in more clear. So let's suppose here I am just giving you one problem. So you have the image size as 7 cross 7. Okay, and you are using stride equal to 2, and padding you are just defining 0. So by default padding will be 0. Okay, and stride you have taken as 2. So what will be the dimension of image after performing a convolution operation? So at that time of the interview you are not going to do matrix multiplication. I want to multiply this and multiply this. There is a shortcut formula for this, that is a n plus 2p by s, n plus 2p minus f divided by s plus 1. Okay, so what do you mean by n? N is basically the dimension of your image. If your dimension of your image is suppose 7, here the 7 cross 7, so n represent as 7. Okay, p basically represent as padding, so by default padding will be 0. So 2 into 0 you are just going to get as a 0. Okay, and f represents that what is the size of the filter you are going to use. Here you are using the size as 3 cross 3. Okay, so size of the filter will be 3. Okay, you can whenever if there is a 5 cross 5, then f will be 5. If there is a 7 cross 7, then f will be 7. And by default you are using here stride equal to 2, then you have to give the s equal to 2 plus 1. Okay, into that is basically you are using 7 cross 7, then again it is you can just provide the same as it is. So once you will perform only for the one, you will just get the multiplication of another also. So whenever you are just using n equal to 7, okay, so we are using image size as 7 plus padding is 0. So 7 plus 2 into 0 0, 7 minus 3, you are using the kernel size or feature detector or number of filter size you are using as 3 cross 3. Okay, so means you will just keep in place of f equal to 3. Okay, so here 7 minus 3 you are getting as 4. Okay, so 4 divided by stride you are using as 2, so 4 divided by 2 you are getting 2. Then after you are adding plus 1, so 4 divided by 2 you are getting 2, plus 1 you are getting 3. Okay, so size of image you are you are getting for after performing one convolution operation as 3. And here also you will get the same as it is output, because you the dimension of this particular height and width of this particular image is same, 7 cross 7. So here also you are getting 3. So here you are able to see you are getting the image size as 3 cross 3. So now we have what we have done in the previous, like let's suppose we have just taken in the stride as a 1. You are getting the size as a 5 cross 5. How you are getting the size? You can just calculate with this particular formula. So you will keep n equal to 7 plus 2, padding is by default zeros, means 7 plus 0 means 7 minus the filter size you are going to use, that is a 3. By default also we have just used before also, filter size as 3 cross 3, means 7 minus 3 you are getting as a 4, and divide by s, you are by default you are using stride as a 1, means you are just skipping one stair or one row, one column at a time, or one row at a time. Okay, so you are using stride equal to 1, means 7 minus 3 divided by 1 you are getting as 4, plus 1 means 5. Similarly you will get 5, so 5 cross 5, this is what you are getting, 5 cross 5. Okay, this is the output you are getting after performing the convolution operation. So this way you can explain during the interview time also, when this is the general question they are just asking. So even just remember this particular formula and what the n, p and f and s represent this thing. So I hope so it is really clear to you, and we will see this thing more detail in the coding part. So after one convolution operation, what will be the dimension of image we are going to see, because there we are going to see what the n, how many number of filter we are going to use, size of filter we are going to use, and that is a kernel size, what stride we are going to use, what padding we are just defining, and what dimension of image it is. Everything you have to define during the coding time. So at the time of the coding part you will be 100% clear with this particular topic. So I hope so you are clear with the convolution operation. So after convolution operation, what you are doing, you are just applying the ReLU activation function. So ReLU activation function, on top of that you are just applying the ReLU activation function, means whenever you will get somewhere as a negative, you already know about the ReLU. If you are just reached to the CNN network, building the CNN network, means ReLU by default the range they are using a max of x comma 0, means where you will get the negative pixel, it will just become as a 0, means that particular pixel or that particular area does not represent any important feature, means that particular area does not contain any important features, that's why you are just removing that particular area. Okay, so this is the function of the ReLU. In the next video we are going to see about the pooling part, how we are using the pooling, and after the performing the convolution layer, why we are using the pooling layer, and how different type of pooling layer we are going to see. Okay, so I hope so you are clear with this video. That's it for this video. Thank you.